Hey, there's that crazy guy again that says there's no such thing as magnetic attraction. Yes, dear, he's quite crazy. Yes, crazy like a fox. I forgot to do a quick little demonstration, one last thing, and show you a neat little trick. Yes, more fun with CRT tubes, because we have a dielectric device here, projecting dielectricity at our screen. Now you'll notice we're getting a dielectric counter avoidance, or what you'd call attraction. You obviously can't necessarily see that. You don't know if I'm actually pressing it towards the screen, but I'm actually, the magnet, quote unquote, is being pulled to the screen. Same thing along either pole. If I actually bring it like this, I'm like to crack the screen with a metallic magnet, but if I even bring it to where it went to fall into my hands, it's still attracted to the screen. You see this black ring, and then the white fuzzy ring, and then our white edge. Anyway, I'm getting attraction. Dielectricity to dielectricity. Something else I'd like to show you too. Let's point it over at just white space on the wall. And let's look. Remember, we get electrification. Phi times I equals Q, electrification in Planck's. So we have a stationary magnet, quote unquote. And we have compound. There's something that nobody talks about. You really won't read in books, because they talk about moving a magnet against a dielectric reflector or a copper coil and getting electrification. But it's compounded movement. There are 10 pressure zones, 4 field zones, and 2 ether modalities on any magnet. Obviously 2 ether modalities: magnetism, dielectricity, right? 4 field and 360 degree rotation. We have magnetism, dielectricity, dielectricity. 360 degree rotation, we have those 4 field pressures: centrifugal, centripetal, centrifugal, dielectric, and 360 degree rotation, right? So, compounded movement of the magnetic and the dielectric, right? Just the magnet sitting there, we already have magnetic reciprocation centrifugally and centripetally. I move it physically in space and time. Remember, there's only 4 principles of electrical engineering: magnetism, dielectricity, which we already have here in rather good abundance, space and time. We have to move this and compound what is already going on in rotation, in spin, existing spin, spinning here right now. You see the spin? No, of course you don't. Magnetism is reciprocating. We can see that from our centrifugal, divergent, intercentripetal, convergent fields in our dielectric inertial plane, concentrated here and returning obviously at the centripetal, reciprocating magnetism. So, compounded movement of magnetism. So I'm taking what is already spinning and I'm physically rotating the object in which it is spinning. So we have compounded field dynamics. You're taking what is already spinning in the stationary physical object and you're compounding that by physical rotation of what is already moving in the field. Remember, fields don't see physical movement. But electrification, what you're doing is churning up the ether. Actually, Charles Proteus Steinmetz said that electrical generators they did a lot of churning up of the ether, which is correct. So we have compounded. Now see what happens as I move our field in space and time. I'll need to bring that over there. What is happening? Now you notice the shift here? Watch the shift. Remember, we've already got existent spin from a magnetic reciprocation on the physical object sitting there stationary. But what is sitting there stationary is the physical object that you see, the quote-unquote so-called magnet. But we have existent spin, divergent and convergent reciprocation going on in the stationary magnet. So you're compounding field movement in space and in time in what is already existent. So you're taking pre-existent spin and reciprocation, and you're compounding that by adding a space-time variable, and that is how we get electrification against a dielectric reflector, i.e. your copper coils. So let's add space and time factor into what is already reciprocated. We can already see the spin from the dielectricity being projected from the CRT tube, correct? Correct. Centrifugal, centripetal, convergent, divergent. Now we compound that with our two additional factors of electrical engineering, space and time, right? Right. So now look what's going on. Obviously I can only rotate it so fast with my hand. So we have 10 field pressure zones and 360-degree rotation. Centrifugal, the centripetal, leaving centripetal, centrifugal. Dielectric inertial, centrifugal, centripetal, leaving centripetal, entering centrifugal, leaving centrifugal, entering dielectric inertial. So, two ether modalities, dielectricity and magnetism. 4 pressure zones, centrifugal, centripetal. 6, 2, 2, and 2. 6, centrifugal, centripetal, centrifugal, centripetal. That's 4. Dielectric, dielectric, 360-degree rotation. Here you see 6. 1, 2, 3, 4, 5, and 6. This is 1. Now you can see your 10 pressure zones. Dielectric inertial, centrifugal, centripetal, leaving centripetal, centrifugal. Dielectric inertial, centrifugal, centripetal, leaving centripetal, centrifugal, dielectric inertial. So 2, 4, 6, and 10. Dielectricity, magnetism, centrifugal, centrifugal, centripetal, centripetal. Either side, dielectric inertial. 10 boundary zones, centripetal, centripetal, centrifugal, etc., and 360-degree rotation. So we have compounded movement of what is existing and pre-existent spin for electrification. This is the churning up of the ether that Oliver Heaviside and Charles Proteus-Steinmetz talked about. This is how we get electrification against a dielectric reflector, which is what copper, silver. This is what these are. This is your conductors. You can't actually see this, but you can actually feel the attraction. I'm going to show you a neat little effect here in a second. If you have a large CRT tube like this, it's a really fun demonstration. I won't tell you what's going on, but I'll let you feel it for yourself, and then you can report back, or you'll just see the results for yourself. I won't tell you what's going on, but I want you to try it if you have one of these. Not this magnet, this is a large beast, very heavy one. You can actually still feel it here. But it's harder to feel because it's a really heavy magnet. So, now do we understand about compounded movement? And you see how we're getting attraction? Why am I getting attraction, huh? If this is electrons, why would I be getting attraction to the CRT tube, right? No. It's dielectric voidance. Obviously not as much here. I am still getting in here to the centripetal. As you can see a little white spot right there, I am still getting a traction, or dielectric voidance, on the face. But nothing like I'm getting here. This is about, obviously this is subjective, but 2 to 3 times as much pull, because this is our dielectric inertial plane along the magnet. So here I'm getting quite a bit of a traction, quote unquote. Here, some, nowhere near as much. Some. Still getting it, especially as I get closer. Here, not really. As I get closer, you notice the bright spot increases, more traction. Here, instantly the same, but a lot more. A lot more here. Either way I have it, I still have centrifugal magnetism displacing the dielectricity from the CRT tube. Now let's on for a little experiment. If you have a powerful little disc magnet, this one's a ring magnet, doesn't matter if it's a disc magnet or a ring magnet, but just position it gently on one finger and do this. Now look at the field behind here. Remember, this is our centrifugal divergent, this is our centripetal convergent here in green. Now watch as the boundary between the two centripetal and centrifugal fields fluctuates like a butterfly. This is not what I'm interested in showing you, but you'll notice, you see this little fluctuation? That's not what I'm interested in showing you. What I'm interested in showing you is we have dielectricity entering our dielectric inertial plane of our powerful little neodymium. Okay? This will also work with a ferrite magnet too, by the way. More powerful the better, however. So just take this, balance it on one finger, and lightly drop it. By drop it, I mean slowly. Like this, and tell me, report what you get back. I'm not going to tell you what's happening. You can actually see what's happening behind here from the color displacement from the dielectricity. You notice what happens to our centripetal as I drop it towards gravity? What happens? What happens also below? Look what happens here in green, and look what happens here in green. Now, do you see our centrifugal zone? I mean our dielectric inertial plane zone between our two conjugate fields? Watch what happens as I raise and lower it. You notice it looks like a bird pattern, a butterfly formation, like it's flapping away from you. Not meant to show that to you as being pretty, but just as look what's going on in the field dynamics. So what happens is I'm having dielectricity enter into the magnet from the CRT tube into the magnet. So I'm actually bringing power, capacitance, into the magnet as I'm dropping it towards the Earth. Correct? Correct. So, now look at what's happening on the field. Same thing will happen over here on the edge. Concentrated right here because our discharger of dielectric lines of force snapping, what is incorrectly called electrons, the quote-unquote electron gun, is right here in the back in the center. But do this yourself if you have a large CRT tube. I don't think it works as well on a small one. With a powerful disc magnet, slowly, gently drop it, and report to yourself, not to report to me, just report on what you feel. So you know what's going on. We're having dielectricity enter into the magnet, increase its capacitance. We're having this tighter constriction of the interatomic of the interatomic dielectricity of the quote-unquote magnet here as I'm slowly dropping it on one finger so you can feel it more. So just do this and report back, or just report to yourself as to what happens and see if you can explain it. I know what's going on, but let's see if you can figure it out. Let's call this puzzle number 3. I particularly don't like puzzles, but I don't want to persuade you one way or the other by saying, well, this is what's going on. I'll let you say figure it out for yourself, experience it for yourself. You know, it's good to experiment, it's good to tinker, but more important than that, you have to have a logical premise for your tinkering. That's why Nikola Tesla made fun of Thomas Edison for taking so long to perfect the bloody light bulb. Thomas Edison was not that bright. He was just a really, really prolific tinkerer. I think Tesla said something to the effect that if you let me have at it, I would have cracked the light bulb problem a lot earlier, which of course is true. So, that's a neat little trick. I won't tell you what's going on, I won't tell you the effects I'm feeling, but I'll let you see for yourself. So, I want you to have a complete understanding of compounded field movement. You're physically moving and rotating in space and time what already has, in physical static form, existent field, reciprocation, and spin. This is already spinning, sitting here like this. Physical object isn't moving. Move the physical object in space and time, here we get electrification against our dielectric reflector, our coil. You see this? Physical object not moving. Already have existent spin, centrifugally, centripetally. Look, this is a physically static object, right? So what's going on to form the pattern back here? Compounded field reciprocation by physical movement in space and time. This is electrification. Crude analogy? Yes, but it's illustrative. I mean, it's hard to show electrification. I could spin this thing against a copper coil and show you the resultants from the voltmeter, but everybody's seen that, right? Right. It's good to have a good physical analog. Pre-existent spin. Compounded. Physical movement compounding the already existent magnetic, divergent, and convergent spin. Remember, magnetism is Dielectricity in discharge. It is dielectric radiation. Electrification. 4 principles of electrical engineering. Dielectricity, magnetism. Already got it. All we have to do is space and time. Which, of course, prime mover. The whole answer to everything in the world is solving the prime mover. Have to have water moving, have to have something moving to cause this to get electrification. Right. So, now the trick is you need to work backwards. Use Platonic retroductive methodology to figure out. You can't sidestep a prime mover, but it might be possible to work your way around it. I won't go into detail on that, but there's obviously no free energy. I'm not an over-unity person at all. It takes pressure, it takes force to pierce the ether. But what if I were to tell you that to pierce the ether, instead of doing this, I could apply pressure, static pressure, and get electrification? What if I told you instead of doing this number, I can get this number by applying static pressure? Static pressure. You cannot crack the mystery of getting electricity unless you have an absolute hardcore grasp of what's going on in this thing that you call a magnet, which is not a magnet, it's a dielectric object. I cannot get that through to you. Some people I can, obviously. I don't mean you specifically, whoever's watching. But compounded field movement in what is already spinning and causing movement in what is already existing spin. Compounded field reciprocation by adding a space and time variable, but now we're talking about a prime mover. Water movement, sunlight, nuclear. But, without going into detail, what if I'm able to apply compression? Remember, magnetism is spatial. Polarization equals the creation of space. What if I'm able to apply static pressure to what is polarized and distort space and circumvent the prime mover? So, instead of having perpetual prime mover movement to drive space-time variable and space-time dielectricity and magnetism for creation of electrification, what if I'm able not to get around the prime mover, since you actually have to have movement, but actually not circumvent or eliminate, but actually get around it by, instead of moving the physical magnet, compressing field and still moving space and time by applied static compression? But I won't give you the answer to that. But what if that were possible? Can you think of that? Can you actually get that through your head? Can you grasp that? That instead of doing this, all I'm doing is circumventing it through pressure. Field pressure. We already have space and time in our polarized field. So applying special pressure without going into detail, we are able to get electrification without physical movement. The only thing I'm getting from physical movement is compounded space-time movement against a dielectric reflector. So, to circumvent that, apply pressure to the fields, which is resultantly the same thing as a space-time variable by physical movement. Do you understand that? All I'm doing is I'm replacing physical movement with field compression. Since magnetism is polarized and space and time are posterior attributes to polarization, that is what polarization is definitionally. This is magnetism divergent and discharge from dielectricity. Field compression, special geometry to get space-time movement and a static compression. I won't go into more details on that. If you want elaborations on it, I'm not going to give it to you. I'm not making any claims, so don't go reporting to other people that I've made a harebrained claim that I'm not able to back up. I've only made a statement. I've not made any claims. I've not stated that I have X or I have Y. I've just made a statement that you should think about. I hope I've made things a little bit more clear to you. Here we have our dielectric reflector, our huge piece of copper. It's wonderful how you can't actually see it that well on this. It just floats to the copper plate, but everybody's seen that, and that isn't important for anything. Still need our dielectric reflector. Still need our magnetism and our dielectricity, space-time variable. But field compression versus physical object movement. Because we already have, as you can see the pattern here, there is existing reciprocation of movement. So we can't eliminate the prime mover, but what we can do is apply static pressure and get a resultant electrification. I'm not claiming this. I want you to think about it. Okay? I need to stop making these videos at 3 a.m. Need more coffee. Thanks for watching.